Here we have a quadratic. It's currently in vertex form, and I want to find a couple key pieces of information. So the first thing I want to find is the vertex, since it's already in vertex form. I also want to find the y-intercept, and I want to find the roots or the x-intercepts. Okay, so first of all, to find the vertex, it's already in the form y equals a times x minus h squared plus k, where our vertex is h and k. So h is 3 and k is negative 18. So my vertex is at 3, negative 18. So that's probably the easiest part of this whole thing is finding that vertex because it was already in the correct form to do that. Now second, we're going to find the y-intercept. So there's several different ways you can approach this. So let me rewrite the equation here. So there's several different ways you can approach it. So we know if it's in the form y equals ax squared plus bx plus c, the y-intercept is always this constant or c term. So I could take x minus 3. So I take this x minus 3 here, FOIL it out, then distribute the 2 into the trinomial that I get. Then I subtract 18. Then I would have it in this form, which would allow me to find the c term. The easier way to do that is I know if I'm trying to find the y-intercept, I have an xy coordinate plane. So if I have an xy coordinate plane, and I'm on the y-axis, wherever it is, I know x is equal to 0. So if x is equal to 0, I'm on the y-axis, that will give me my y-intercept. So I'm going to set the x equal to 0. So y is equal to 2 times 0 minus 3 squared minus 18. So y is equal to 2 times 0, not 0, negative 3 squared minus 18. Negative 3 squared is positive 9, so y is equal to 2 times 9 minus 18. Y is equal to 2 times 9 is 18. 18 minus 18 is 0. So really, my y-intercept is at the point 0, 0. Okay, so that gives me my y-intercept. So let's write it over here. So the y-intercept is equal to 0. So I found my y-intercept, I found my vertex, and now what's left is to find the roots or the x-intercepts. Okay, so we're going to write this equation down one more time. So I have y is equal to 2 times x minus 3 squared minus 18. Now there's several different ways, again, that you can find the roots. You can take this equation and you can FOIL it out, put it in the form y equals ax squared plus bx plus c. You can use your factoring with the zero product property. You could use completing the square. The easiest way, though, if I'm on the x-axis, because I'm finding the x-intercepts, I know y has to be equal to 0. So I have 0 equals 2 times x minus 3 squared minus 18. Once I get it in this form, I can identify that the easiest way for me to solve this is just to isolate the x. So first I'm going to add 18 to both sides. So I have 18 is equal to 2 times x minus 3 squared. I divide both sides by 2. So I get 9 is equal to x minus 3 squared. Now to get rid of that squared, I'm going to use the square root. So that gives me not only positive 3 but negative 3, because the square root of 9 is any number times itself that gives you that number. So positive 3 times positive 3 is definitely positive 9. Negative 3 times negative 3 is definitely positive 9. So I have plus or minus 3 is equal to x minus 3. So since I have one expression, this x minus 3, it has two different solutions. I'm going to write it out 2 times. So x minus 3 is equal to 3. And x minus 3 is equal to negative 3. I add 3 to both sides, so x is equal to positive 6. Here, x is equal to 0. So my two x-intercepts are x equals 6 and x equals 0. And if I had to write them as ordered pairs, I'm on the x-axis, so the first one would be 6, 0, and the other one would be 0, 0. Okay? And then I have a y-intercept. The order pair would be 0, 0. And I already have the order pair for my vertex.